Hello students, myself Jyoti Kiran, Assistant Professor, Government First Grade College, Tiptur. Today I am going to talk on the concept reduction formula. So in this session, I am going to discuss on the reduction fifth trigonometric function, secant and cosecant reduction formulas. Let us take the given function integral of secant to the power of nx dx as in, as already we know about in the in for the given function, representation for the given function. Then divide and multiply by secant square x. It will become secant to the power of n minus 2x secant square x dx. Then integrate by parts. So already we know about integration by parts. First function integral of second function minus integral of second function into derivative of first function. Here secant to the power of n minus 2x is the first function. Then secant square x is the second function. Secant to the power of n minus 2x. Integral of secant square x is tan x minus integral of tan x. Then derivative of first function. Derivative of first function is secant to the power of n minus 2 is there. Then its differentiation is n minus 2 secant to the power of n minus 3x. Again differentiation of secant x is secant x into tan x dx. In the next line, secant to the power of n minus 2x tan x minus, here n minus 2 is the constant right outside the integral sign. Then remaining function becomes secant to the power of n minus 3x into secant x. Its power is 1 is there. N minus 3 plus 1, it will become secant to the power of n minus 2x. One more function is remaining, that is tan x into tan x. It is tan square x dx. Then secant to the power of n minus 2x tan x minus n minus 2 integral of secant to the power of n minus 2x. Here tan square x differentiation is secant square x minus 1 into dx. Then secant to the power of n minus 2x tan x minus n minus 2. Then multiply this function to secant square x minus 1, plus 2 and minus 2 get cancelled. Remaining is power n x into dx plus, then here we get minus of minus plus is there. Then we have to write n minus plus n minus 2 into secant to the power of n minus 2 x dx. Then in is equal to secant to the power of n minus 2x tan x plus n minus 2 secant to the power of n minus 2x dx minus, this will be right in the last third function, minus n minus 2 integral of secant to the power of nx dx. This can be written as in. Then transposing the last term on RHS to LHS, we get. So this is the last term. This can be transformed to LHS. In already is there in the LHS side. In plus n minus 2 in. Then it will become secant to the power of secant to the power of n minus 2 x tan x plus n minus 2 integral of secant to the power of n minus 2 x dx. Then here take in as a common term, then it will become n minus 1. N minus 2, here coefficient is plus 1, then it will become n minus 2 in, which is equal to secant to the power of n minus 2x tan x plus n minus 2 secant to the power of n minus 2x dx. Dividing throughout the equation by n minus 1, that is the coefficient of I1. Then it will become in is equal to 1 divided by n minus 1 secant to the power of n minus 2x tan x plus n minus 2 by n minus 1 secant to the power of n minus 2x dx. What is in? Here in is integral of secant to the power of nx dx, which is equal to 1 by n minus 1 secant to the power of n minus 2x tan x plus n minus 2 by n minus 1. These integrals can be written as n minus 2. So this is the required reduction formula for secant to the power of nx into dx. So next we move on to evaluation with the limit 0 to pi by 4. So here for the given function can be taken as in. Already we evaluate this integral. So this is the reduction formula for secant to the power of nx. With here in this problem we have to apply the limit 0 to pi by 4. So here 1 divided by n minus 1 constant, secant to the power of n minus 2x tan x with the limit 0 to pi by 4, plus these are all constant function. Here there is no necessary to apply the limit. Okay, then in is equal to 1 divided by n minus 1 is constant is there. Apply the upper limit. Secant to the power of n minus 2x, x is pi by 4, then tan pi by 4. Tan pi by 4 is 1, secant pi by 4 is root 2 is there. Root 2 to the power of n minus 2, then its lower limit. Lower limit ಏನಾಗುತ್ತೆ ಇದು 0 ಆಗುತ್ತೆ. Plus n minus 2 by n minus 1 in minus 2. So this is the required formula. Formula for the integral of 0 to pi by 4 secant to the power of nx into dx. Okay, next we move on to the problems related to the reduction formula secant to the power of nx dx. So let us see the first problem. In this problem n is equal to 3 is there. In the second problem n is equal to 6 is there. So we have the reduction formula. For this formula we have to take n wherever we can see the n here we have to put n is equal to 3. We get this equation 1 by 2 secant x tan x plus 1 by 2 I1. So again evaluate for I1. 1 by 2 secant x tan x plus 1 by 2. What is I1? That means n is equal to 1. Here in the place of n write 1. That is secant x into dx. Then already we know about the integral of secant x. Integral of secant x is log of secant x plus tan x. That is the required solution for the first problem. So next second problem is there. Secant to the power of 6x dx is there. Take n is equal to 6 in the reduction formula. So we get 1 by 5 secant to the power of 4x tan x plus 4 by 5 I4. Again write n is equal to 4 in this same formula. We get this equation 1 by 3 secant square x tan x plus 2 by 3 I2. Again we have to take n is equal to 2 in this formula. We get 8 by 15 integral of n is equal to 2, that means secant square x into dx. Then integrate this. Integral of secant square x is tan x. This is the required solution for problem number 2. Okay, so next we move on to next problems. Second example, 0 to pi by 4 secant to the power of 4x dx plus 0 to pi by 4 secant to the power of 5x into dx. So in the first problem, take n is equal to 4 in the reduction formula. We get, already we solved in the previous problem, we get root 2 whole square by 3 plus 2 by 3 I2. Then 2 by 3 plus 2 by 3 for I2. Take n is equal to 2 in the reduction formula, secant reduction formula. We get secant square x into dx. Integral of secant square x is tan x with the limit 0 to pi by 4. 2 by 3 plus 2 by 3, final answer is 4 by 3. So in the next problem, take n is equal to 5. Already in the previous session we solved this problem. The solution is root 2 by 3 root 2 whole cube by 3 plus 3 by 4 I3. Again put n is equal to 3. We get this equation. Then put I3. Then we get I. For this we get 0 to pi by 4 secant to the power secant x into dx. Again simplifying secant x, integral of secant x is log of secant x plus tan x. Apply the limit for this. Log pi by 4 is root 2 plus tan pi by 4 is 1. Lower limit is 0. That is the required solution for the second problem. Next we move on to the last a trigonometric function cosecant to the power of nx, where n is a positive integer. This is the reduction formula related to cosecant nx. So in this reduction formula also we have to follow the same procedure as already we solved in secant to the power of nx dx. Divide and multiply by cosecant square x. then integrating by parts, we get this equation. First function, integral of second function minus of integral of second function, then derivative of first function, cosecant derivative, n minus 2 cosecant to the power of n minus 3x minus cosecant x cot x dx. Okay, here we have to simplify this. N minus 2 cosecant to the power of n minus 2 cot x, and cot x is there, we get cot square x. Again cot square x is cosecant square x minus 1. Remaining all will remain, remaining terms will remain same. We have to write the same terms here. In this place also we just simplify this. Here we write it as n minus 2 multiplication n minus 2 cosecant to the power of n minus 2 x into dx is there, then minus cosecant to the power of n minus 2 x cot x plus n minus 2 integral of cosecant to the power of n minus 2, the last term, cosecant to the power of n minus 2 x dx minus of this term n minus 2. So integral of cosecant to the power of n x is can be written as in. Then transposing this term to the LHS. Already in LHS we have in is there, in plus n minus 2 in. Then it will become minus cosecant to the power of n minus 2 x cot x plus n minus 2 cosecant to the power of n minus 2x dx is there. On simplifying we get, so here n minus 2, then its coefficient is plus 1, it will become n minus 1 in. Then we have to write all the remaining terms. So divide throughout the equation by n minus 1, we get this equation. So this is the required reduction formula for cosecant to the power of nx into dx. Okay, next we have to evaluate the cosecant to the power of nx dx with the limit pi by 4 to pi by 2. First we have to write down the required reduction formula. Then then put the limits, upper limit and lower limit. So pi by 4, pi by 2, this will remain the constant. By applying these limits we get cosecant root 2 n minus 2 by n minus 1 plus n by 2 by n minus 1 in minus 2. Then pi by 4 to pi by 2 cosecant to the power of nx dx. This is the required solution for the given problem. So next we can move the problems on related to the reduction formulas. Cosecant to the power of nx dx. Here n is equal to 5 is there and n is equal to 6 is there. Putting n is equal to 5 in the cosecant reduction formula without limit. Okay, na? So on simplifying we get I3. Again put n is equal to 3 in the same formula, we get I1. Then I1 is nothing but cosecant nx is there, cosecant x. Integral of cosecant x is log of cosecant x minus cot x. This is the solution to the related to first problem. Next, cosecant to the power of 6x. Taking n is equal to 6 in the required reduction formula, we get I2. Then put n is equal to 2 in the same formula, we get cosecant square x dx. Then simply integrate this cosecant square x. Integral of cosecant square x is cot x. That is the required solution. Here cosecant to the power of 6x is there. So we have to take n is equal to 6. Same procedure we have to follow. In the substitute n is equal to 6 in the standard reduction formula, we get I4 and I2. Then simplify I4 and I2, we get cosecant square x integral is minus cot x. Apply the limits for this function, we get the answer 28 by 15. 28 by 15. Thank you.